Here's a great practical question that applies everything we've learned in electricity. This is like a culmination question with our thermal physics unit. Okay, so what we're going to do is try to analyze how an electric water heater works using a simple circuit that just incorporates a resistor. So I showed you how resistors work, and I showed you and I talked about how they get hot when current flows through them. So you have this at home. Most of us in Ghana have water heaters attached to our showers, and they use this simple circuit that applies the voltage from the wall, or the potential difference, across a resistor. The resistor gets hot, and then it heats water inside. Okay, and if you look at the label on front, it would give you the power rating. It would tell you how much power does that water heater have. Okay, so that power means how many joules per second of heat energy is it going to put into the water that is stored inside of the heater. Okay, so if I looked at this circuit and I knew that I applied it to 220 volts and my resistor was 22 ohms, how would I go about calculating the power? Okay, so remember, power is equal to current times voltage. All right, so how would I use the information that is in that circuit to be able to figure that out? Well, I have the voltage, that's 220 volts, but I don't have the current going through there. Okay, but I can figure out the current using the resistance and Ohm's law. So V equals IR. Those are two equations I need to be able to play with. So to get the current, I would just take the voltage divided by my resistance is going to be equal to my current. So 220 volts divided by 22 ohms is going to be equal to 10 amperes. Okay, so the total current flowing through there is 10 amperes. Okay, so I'm just going to erase this bottom part right now. Now, in order to calculate the power that is going to be going through that heating circuit that I have over here is equal to the current times the voltage. So the current, which we just calculated, was 10 amperes, times the voltage, which is 220 volts, is going to be equal to 2,200 watts. All right, so that's a 2 kilowatt heater, which is a very common, simple, slow, moderate heater that you would have. For example, an electric kettle, or I don't know, if you looked at the water heater that you have in the bathroom, it probably has a higher rating than 2 kilowatts, but 2 kilowatt is a fairly common amount of power in a water heater. Okay, so using that 2,200 watts, what can we do with it? Well, how much heat does, instead of a 2,200 watts, because that's kind of weak, let's take a look at a 4,000 watt heater. So how much heat does a 4,000 watt heater supply in 5 minutes? So after building that circuit and making a 4,000 watt heater, how much heat would be supplied in 5 minutes? So what I have to remember is, what's a watt? Okay, so 4,000 watts is equal to 4,000 joules per second. Okay, so that's the rate of energy being put into my water heater. Okay, so when we're thinking about the amount of heat put in, or the temperature change of water, we're thinking about the rate of heat being put in. So 4,000 joules per second in 5 minutes. What do I need to do that 5 minutes? I need to turn it into seconds. Okay, and then if I get the total amount of seconds that I'm applying that, I'd be able to figure out what to do next. Okay, so the total heat, which I'm going to say is Q, if you remember from the last unit, is going to be equal to power times time. How do I know that? Because the units tell me. Joules per second times seconds. The seconds will cancel out and give me joules. Okay, so power times time would give me the total amount of heat that's put in. So 4,000 joules per second times 5 minutes. Now, minutes and seconds are not the same unit, so I got to convert, times 60 seconds per minute. The minutes now cancel out, the seconds will cancel out, and then I'll be left with 1,200,000 joules if I used my calculator. Okay, so that's how much heat, 1,200,000 joules. That seems like a lot of heat energy that a 4 kilowatt or 4,000 watt heater is going to put in 5 minutes. Well, let's see what else we can do with that. Well, here is an example of, let's say, a 4,000 watt heater, a 4 kilowatt heater which contains 30 kilograms, 30 liters or 30 kilograms of water. Calculate the temperature change of the water after 5 minutes of heating. Okay, here is your grand finale, the big question. Now I understand how electricity does something cool like heating water in a water heater. Okay, so it's a 4,000 watt water heater, 30 kilograms of water, 5 minutes of heating. All right, so in the last question told us how much heat was put in. So the heat that was put in 5 minutes is equal to 1,200,000 joules. And we figured it out by taking the power and multiplying it by the time in seconds to get 1,200,000 joules. And then where is that heat energy going to go? It's going to be going into changing the temperature of the water, okay? Where water is 4.19 joules per gram degree Celsius, if you remember, or Kelvin. That's the specific heat capacity of the water. Okay, so I have 30 kilograms. This unit is in grams, so I got to convert my mass into grams for this particular equation. All right, so then if I rearrange the equation, Q divided by MC is going to be equal to delta T. All right, I'm just moving MC over to that side. And then I can plug all my numbers in. Okay, so 1,200,000 joules divided by the mass, which is 30,000 grams. There's 30,000 grams and 30 kilograms times 4.19 joules per gram degree Celsius will give me a temperature change of 9.5 degrees Celsius. I worked it out before I made this video. Okay, so wow, it seems like I would have thought 1,200,000 joules would have really changed the temperature by a lot, but you can see with 30 kilograms, that's a large mass of water. 1,200,000 joules only changes the temperature by 9.5, but that's a good safe temperature to heat the water in Ghana. The water probably comes in at a little higher than room temperature, okay, and then heating it 9.5, that puts it at body temperature, so the water is kind of cool. Maybe after another 5 more minutes, it'll be uncomfortably hot. Okay, you don't want it too high above body temperature because that can start to burn you. Okay, so that sounds about right for a 4,000 watt heater. Okay, so this process here is something that you would have to work through and memorize. I can guarantee I'm putting this on your final exam, so make sure to practice this, okay, because it's a good combination of electricity and thermal physics. All right, this also tests your knowledge of power times time to get the energy, and this here tests your ability to calculate the power of an electrical circuit. First, you have to find the current, and then the current times the voltage tells me the power. Then I can go and apply everything I've learned already. Okay, so let's put that into practice. Here's a good example problem of what could be on your final exam. A student builds a simple water heater using a circuit shown in the diagram. She places the resistor in 100 milliliters of water. Calculate the temperature change of the water after 10 minutes of heating. Okay, so if I just, here would be 100 mils of water. We're not going to worry about the container. We'll just imagine that that water is somehow suspended miraculously in air and she's only heating the water. Okay, so how are we going to do that? It's the same thing. So remember, step number 1, we needed to calculate the power of circuit. Okay, step number 2, power times time is equal to Q. And step number 3, Q equals MC delta T. Okay, so how do we calculate the power of the circuit? Let's erase this bottom stuff and just go with that. First part, the power of the circuit is going to be equal to current times voltage. I need to be able to figure out the current in that circuit using 12 volts divided by 5 ohms is going to be equal to 2.4 amperes. Okay, so that's using Ohm's law. Okay, so that tells me 2.4 amperes is the current. So power is equal to 2.4 amperes times 12 volts, and that should give me around 28.8 watts. That's not that powerful of a heating circuit. Okay, but then after getting that, I should be able to then calculate the amount of heat added. Okay, so the amount of heat added is equal to the power times time, which is 28.8 watts, times how much? 10 minutes? 10 minutes times 60 seconds is going to give me the total amount of heat added. And then if I take this value, so if I take that value and then put it into Q equals MC delta T, okay, I'm not going to finish that part. I want you guys to do that. If I would do that, now the mass is 100 grams, specific heat capacity is 4.19. If I did that, I should get a change in temperature of 41.2 degrees Celsius. So I want you guys to try that and see if you can get that. Okay, so the reason she's getting a larger change is because it's a much smaller mass of water that she's heating. All right, and here's a good example of what your final exam problem would look like for combining thermal physics with electrical circuits. Now I could do things like change the fluid. It might not be heating up water. I could be heating up a metal. Okay, so there's a lot of different ways I can change this up, but you need to understand the process of calculating the power of a circuit, the total amount of heat delivered by that circuit, Q is equal to power times time, okay, which you guys have practiced in the thermal unit, and then putting that into the equation for specific heat capacity. And that's that.